Now let's look at some special cases. We have x plus y is greater than 3 and x plus y is less than -1. So right away you probably can tell that that probably isn't going to work, but let's go ahead and rewrite this. Y is greater than -x plus 3 for the first line, and the next line is going to be y is less than -x minus 1. So scrap the purple. That is a y-intercept of 3, a slope of -1. So right away you notice that they have the same slope. This is open circle or dashed line. Greater than, that's going to be above this line. So therefore we're going to shade over here. Then y is less than -x minus 1. So -1, same slope. So again, it's dashed. I guess I gotta do open circle here. And less than -1, well, that's going to be below the line. So notice it's an empty set. They do not intersect in any way, so this is no solution. So try this example here. Okay, so notice you get the same thing. The equation is y is greater than 2x plus 3, and then y is less than 2x minus 1, and so this is no solution again. Let's go to another special case. Let's look at an unbounded solution set. Sketch a graph of the solution set of the system of inequalities. So we have x plus y is less than 3. So we know, let's do the intercept. So when x is 0, y is 3. When y is 0, x is 3. And then less than is going to be below, and it's a dashed line. Okay, so I'm going to shade below that. So I'm just going to kind of go like this to know that this is where I'm going to shade to kind of start it off. Then the next one is x plus 2y is greater than 3. So I'm going to go ahead and solve for this one because I see that we have a fraction here. So 2y is greater than -x plus 3 divided by 2. So y is greater than -1/2 x plus 3/2. So 3/2, that's 1.5. It goes here. And then this is a slope of -1, 2. So up 1, left 2, up 1, left 2, down 1, right 2, down 1, right 2. Okay, and again, that's dashed as well. And greater than means I'm going to shade above that line. So I'm going to be shading here. So therefore, the solution of the system is going to be between these two lines from here to here. And so it's unbounded. Okay, so it's different. So in other examples we've had, it was enclosed. Like we had a triangle early on, and then in here, this is going to go on forever, right? It goes on forever, so it's unbounded. So later on, we were trying to find, for instance, a maximum or minimum value. When we hit something like this, there, for example, may not be a maximum or minimum value because it goes on forever. So try this example here. Sketch this graph of the solution set of the system of inequalities. So here's the solution set here. It's unbounded again. So they're both dashed lines because it's less than or greater than here. And so the solution set is unbounded again. We'll skip that consumer part. Let's go to nutrition. So let's go to some word problems. The liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, and 90 units of vitamin C. A cup of dietary drink X provides 60 calories, 12 units of vitamin A, and 10 units of vitamin C. A cup of dietary drink Y provides 60 calories, 6 units of vitamin A, and 30 units of vitamin C. So we're going to write a system of linear inequalities that describes how many cups of each drink must be consumed each day to meet or exceed the minimum daily requirements for calories and vitamins. So our goal is to write a system, and then I do have a graph because it's just kind of to help prepare us for the next section. We will be graphing. So let's take a look. We have calories first of all. And so we have at least 300 calories, and X provides 60 calories, and Y provides 60 calories. So at least. So X is drink X, Y is drink Y. So we have 60X plus 60y has to be greater than or equal to 300, and this has to do with our calories. Our next equation, we're going to look at vitamin A. So we need 36 of vitamin A, and dietary drink X provides 12 units of it. So 12x, and then 6y has to be greater than or equal to 36. Then the last one, we need 90 of vitamin C. Oh, let me write this. This is vitamin A. And then we're looking at vitamin C. And so we need 90, at least 90. So therefore, we're going to have 10x plus 30y is greater than or equal to 90. Now, when we're thinking about this, we also need to remember other constraints, meaning that we have to have x has to be greater than or equal to 0. And then y also has to be greater than or equal to 0 because x and y cannot be negative, right? We cannot have negative values here. So we need to remember to write those. That's really important. So here is our system that we needed. So next, what I'd like you to do is see if you can try to graph the system of equations. Try it out, and then I'll have the answer for you when you return. As a hint, you want to reduce each of these, or maybe solve for y, right? Make it in slope-intercept form, and that might be a little nicer, so that way it'll fit really nicely on your graph. So here is the graph. You should have had the pink, purple, and blue lines, and then the points that are important are going to be not 6, 0. That should be x is 0, y is 6 here, 0, 6. 1, 4, 3, 2, and 9, 0. So those are important points. There are vertices here, and so that we'll use that later on. So for this example, see if you can write the system of equations with the public aquarium. And then if you can try to graph it out, but go ahead and at least try to write the system of equations. Okay, so hopefully you wrote the equation here. 8x plus 2y is greater than or equal to 16 for nutrient A. X plus y is greater than or equal to 5. 2x plus 7y is greater or equal to 20. And then an x has to be greater than or equal to 0. And y also has to be greater than or equal to 0. And then if you graphed it, here is the graph. We will be graphing it later on in a later section. So it's not necessary, but it was just good practice in graphing it. We will use that in 7.6 when we talk about linear programming.